Hello and thanks for joining us on another one of our Can You Hear Me Now series of no fluff tech tips. This is Richard Jobson with TerraQuant. Today we're going to drill down on calls with poor voice quality, especially intermittent bad call quality in your IP telephony network. TerraQuant no fluff tech tips make the best use of your time. Your time is most valuable. We come straight to the point, showing you how you can solve service impacting telecom and network problems with practical tips and hands-on demos. Let's have a look at the agenda for today. We're going to start with giving a quick definition of MOS or mean opinion score. Then we will show you a network diagram and some ideas on where to install the monitoring probes. Then we'll jump straight to the demo and show you how to find bad calls literally in seconds. Let's have a quick look at this MOS scale. MOS is typically a subjective scale derived from human beings listening to tapes and voice clips containing impairments and rating them on a scale from 1 to 5, 1 being extremely bad, the worst, and 5 being perfect. Typically, we don't rate anything as being perfect, so in a real scenario, 4.5 or 4.4 is about the maximum you will ever see measured. In live networks, we need to automate this, and this is where technologies such as the E-model and R-factor and PESC and Polka come in to allow a computer to analyze the quality of the speech. In order to be able to instantly spot where packet loss or jitter is creeping into your network and isolate physically which segment is at fault, we need to have probes permanently deployed and monitoring all the relevant legs or segments of the call. These probes need not be expensive. In fact, in the case of Oracle Enterprise Operations Monitor EOM, they are free, but you will need some hardware or virtual hardware to run this probe software. Take for example this call flow here from Alice to Bob. As long as we monitor the legs between the major voice elements, we should be able to troubleshoot where in the network the problem is, such as between the endpoint and the access SBC, or if the endpoint goes directly to the PBX, as in this case here, then to the peering SBC, then to the SIP trunk, which is the carrier circuit, off to the PSTN. We can isolate where the problem is in your network. We span or port mirror the packets northbound, send a copy northbound, and for high density operations we would recommend installing dedicated copper or fiber optic taps. That will take a load off your Ethernet switching infrastructure. If your infrastructure is installed in public clouds such as Microsoft Azure, AWS or Google Cloud or other, TerraQuant Prisms can give you visibility there also. The important thing is that we must capture all the packets to get accurate MOS metrics and see all the important SIP signaling messages. So let's demonstrate how to find calls with intermittent bad call quality quickly with Oracle EOM monitoring tool. Okay, let's see if we can find some calls then with intermittent bad voice quality with indicated by a low MOS score around about 1 or 2. So here we are in the OCOM EOM calls page. We got some established calls. Let's just focus on the finished calls. We would expect them to have some audio. We can see that these calls have audio. Average MOS is around 1.25. That's not too good. But in order to see intermittent calls, we want to see where the MOS dips down below, say 3, down to 1 as we have it here. Let's filter on this minimum MOS, and let's just then look at the message flow diagram to get a picture of this call flow and where the different legs are moving between. We've got this call from Alice. You can click on the invites and see them flowing through the network out to our SIP trunk. They also have, in addition to the SIP signaling, we have little parcels of RTP or RTCP that give
the packet loss and the media and the MOS performance for that phase of the call. And then we have clear forward with the buy being acknowledged by the 200 OK from the carrier, propagated back to Alice endpoint. Okay, let's also drill down with a double click on this particular call. Let's go to the media details tab. We can see this call lasts for about each one of these boxes is 10 seconds. We have information for each RTP stream, and this one particular here, stream number 2, is showing bad MOS with the orange and yellow. So let's go to the media summary tab. Here we can see physically which segment, which vector or which leg of the call the bad performance is being introduced. Here we have a leg from experiencing about 5% packet loss. That hasn't impacted MOS too greatly, but here with a packet loss of 47%, nearly 50%, that's definitely going to crank your MOS score down to 1. We also isolate here which segment of the call it is. It's the lab gateway to SIP trunk that's causing the problem. So we've isolated physically in the network which leg of the call is contributing to the bad voice quality. These other legs have voice about 2 to 3% packet loss. That's not going to impact MOS too badly. Now, if we want to listen to the audio of the call in order to troubleshoot, we can set up EOM to record the media, type in the phone number here, we'll type in 801 for our test endpoints, all traffic to and from, decide whether we want to record video as well as the audio. We want to see the RTP headers, and we now have this nice useful column here that indicates whether this call contains recorded media as well. And drilling down on that call, we can then pull up the PCAP and listen to the audio to troubleshoot effects that go way beyond just packet loss and jitter.
So hopefully you found that useful to quickly find calls with bad voice quality. In the next video of our Can You Hear Me Now series, we will demonstrate how to troubleshoot failed registrations or expired registrations of a SIP endpoint. If you have any feedback or comments on these tech tips, we would be delighted to hear from you. Please message me on LinkedIn. See you on the next Can You Hear Me Now No Fluff Tech Tip videos, and thanks for watching. Bye bye.